we are graphing square roots and cube roots. I'm going to do one square root with you and one cube root with you. Okay, you've done this in Algebra 2. Yes? Not necessarily Algebra 1. Algebra 1 focuses mainly on linear and quadratic. I think you might touch this a little bit in Algebra 1, but it's been a while, so I don't remember. Do y'all remember in Algebra 2 learning IHOD over? If you at least remember hearing IHOD and over. So IHOD stood for inside change, horizontal, opposite of what it sounds or looks like, and then it's your domain that it changes. So here, this +2 on the inside of my house, that's an inside change. Well, it's opposite. It says +2, but it's actually going to go to the -2. And it's a left or right change, yes? Okay, and then the +3 on the outside, that's vertical over. O stands for outside, V stands for vertical, E stands for exact. So it's going to go up 3. Now, no, that's inside. Outside is exact. Yeah. This one's opposite. This one's exact. Now, all parent functions go through the origin. Yes, I believe. Okay, except like rational, but that's different. Most parent functions go through the origin. Let's say that. This parent function does go through the origin. I don't know if y'all remember, but the parent function looks like this. It's the one that has a starting point and then goes forever the other direction. Yes? Okay, so we're going to type in our calculator. We do get to use calculators in my class. My calculator likes to pick and choose when it turns on. For some reason, when I slam it down, it works. Maybe. Maybe not today. Yes, we have a love-hate relationship. Okay, here we go. Okay, so we are going to come here. Second, x squared is how you graph that. See the little radical right above the x squared button? So you have the blue button, x squared, that's how you type the radical. And you're going to do x plus 2. Psst. No. Okay, so then you come out from under the house by clicking the right arrow. See how the house went away? And you do +3. You have to be very careful with that. If you type it all into the house, it will be wrong. Yeah? Okay, so second graph, actually just graph. We're going to look at the graph first. Yep, or I'll take it actually. Thank you. And yeah, perfect. So if you look, like I said, it has a starting point, and then this direction, it goes that way forever. Yes? Okay, so knowing that, we are going to go to our table, second graph. And I always scroll up, because here on my graph, I can plot x from -10 to +10, right? Y also -10 to +10, but x is easier to find. But you'll notice I have all these errors. Well, it's because there's no graph over here. There's nothing at those values. So the first pretty point I have is -2, 3, -1, 4. Now, all square roots will have that error, okay? All of them. Yes? And I'm going to keep going for my pretty points. I do not want my decimals. Can I perfectly plot 4142? No. I'm only going to plot my pretty points. So 2, 5, 7, 6, and then 14, 7. So this is what I get. Now, I'm going to plot those points. Just a reminder, y'all, your height, y is your height. So if you struggle with plotting points, x is your side to side, and y is your height. Yeah? So knowing that, I have -2, and then a height of 3, +3. 1, 2, 3. -1, +1, 2, 3, 4. 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Now I cannot plot the 14, 7. I just fill it in my table. And there's obviously many more points going this direction, but there were none going the other direction. So I put this little dot, dot, dot. So you realize that this is not the end of your table. It keeps going. And this is what it looks like. Now that is a point. That is a starting point, or whatever you want to call it. It started there and it went forever. Yes? Okay. So, and all of them will look like that. However, they'll be shifted up, down, left, right. Okay, they're all going to be shifted in different directions from there. Yes? Okay. Knowing that, let's find our domain. So what I want you to know is that domain is x values, and it only looks at the x-axis when finding domain. So your definition of domain is all possible x values. Now, we're not going to list them, because if we listed all possible x values, well, I want you to realize technically you could use the decimals from here to the right forever, meaning there's an infinite amount. And if we had to list an infinite amount, we'd be in here forever, and I love y'all, but we're not going to stay here that long. So we use interval notation, which we like interval notation. It's easier. So knowing that, the farthest left this goes, well, how far left does it go? -2. So we always do these, we start at the left and we work our way right, because that will keep it least to greatest. So the farthest left it goes is -2. And what's the farthest right it goes? Well, we have an arrow. That means it goes forever. And if you're ever unsure, not the calculator I was using, you can literally keep scrolling. Do you see how my x's keep going forever? I can keep scrolling forever. I could literally go to like whatever number. And you see how it's still going? Okay, y'all, you can still go forever. So does this go forever? Yes. So that just proves that that arrow is supposed to be there. So this does go from -2 to infinity. Now, you can't touch infinity, so infinity gets a parentheses. But our -2 has a point there, so it gets a square bracket. The only time you use a parentheses when you have a number is when there's an asymptote. I don't know if y'all remember what asymptotes are. Nothing we're doing today has an asymptote, so that's not going to happen. Or when you have an open circle, which again, nothing here has an open circle. So every time you have a number today, you should have a square bracket. Every time you have a parentheses, you should have, an infinity, you should have a parentheses. Yes? I know, sorry. Okay, any questions with domain? Okay, so then range, there it is your height. It's your y values. It's looking only at your y-axis. So this is all possible y values. And you go lowest to highest. So you ask yourself, where's the lowest point on this graph? Where's the highest point on this graph? So where is the lowest point on this graph? Well, right here. And how low is that? What's the height of that point? 3. And where's the highest point on this graph? Well, didn't we just prove in our calculator that it goes up forever? Is it going up very fast? No, but it's going up forever, so it goes to infinity. So 3 to infinity. Now, one thing I do want you to realize is down is negative infinity, and left is negative also, negative infinity. If you were to use those, yes. But we're not using those here because it didn't go left forever, it didn't go down forever. So we didn't need those negative infinities here. Any questions with that? Cool? Awesome. So I like to look at my graph for my domain and range. Because there were errors and we started our graph at our starting point, you will see your domain started at -2, your range started at 3. But for your next example, that doesn't help you. Okay? So that only helps you with this guy because we started our starting point. Yes? Okay, so this one's different. This is a cube root. Do y'all see that? Okay, so knowing that, to do a cube root in your calculator, you hit math 4. If you do it any other way, you will not get the right answer. So if you come here, go to y equals, dang it, why do I keep trying to use the wrong calculator? Y equals. You hit math. Do you see how at the 4 it has that cube root? That's the one you're using. If you try to do other methods, I've had people use other methods, it doesn't work. And they're like, this isn't working. And I'm like, because you're doing it wrong. Math 4. Yes? Cool. So cube root in the calculator is math 4. There we have our cube root. And then we just have x minus 2 all on the inside. So this one from our parent function would shift right 2. Because it's inside and it's opposite. So plus or minus 2 goes to the positive 2. Knowing that, let's go to our table. Or actually, let's take graph first. So this is what it looks like. Do y'all remember these? Do you remember that cubic graphs, like x cubed, look just like this but vertical? Okay, so this is just the sideways version of a cubic graph. It's a cube root. It's because they're inverse. So I'm going to scroll all the way to -10. Why am I going to start at -10? That's the farthest I can graph on my graph. Is that where the graph starts? No. These, if you hit graph, did they have a starting point? No, it came from one side, went to the other. Like there's no starting or stopping point. That's only square root. Cube root, you can take the cube root of a negative, and that's why there's no starting or stopping point here. So knowing that, I can't, that's not a pretty point. That doesn't help me, so I'm just going to find my first pretty point, which is -6, -2. And then I'm going to keep scrolling until I find all the pretty points. So I have 1, -1, 2, 0, 3, 1, and then 10, 2. So I can graph all those, which is perfect. Yes? So I'm going to plot those points. But what I want you to realize is it keeps going this way, dot, 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 up, and dot, 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 down. This graph kept going both directions. So -6, 1, 2, 3, 4, 5, 6, down 2. Y is still your height. 1, -1, 2, 0, 3, 1, and then 10, 1, 2. And it looks like a swerve in the road. Like that's what I think of as a road that swerves. Bless you. Bless you.
Thank you.
So domain is my x-axis. So again, it's all possible x values. We're going to go farthest left to right. Well, what's the farthest left this graph goes? Yeah, it goes to the left forever, and it also has an arrow pointing to the right forever. So this is literally just -infinity to +infinity. Now, if I shift this up, down, left, or right, does that change? No, it's still going to go left and right forever. So is your domain ever going to be different for a cube graph? No, it's always going to be this. Always. Okay? Always. Because no matter if I shift this up, left, right, down, doesn't matter. The only thing that's going to change is where your little swerve is. That's all that changes. Okay? It's still going to go to the left and the right forever. So now let's look at range, which is still our y values, which is still only looking at the y-axis. For cube root graphs. Not for square root. Square root, were they always going to be the same? No. Square root changes because your starting point changes. It doesn't go left and right forever. It only goes one direction forever. That's why it's not like that for square root. Cube root, on the other hand, always goes left and right forever, no matter if you shift it or move it around. So here, if I scroll forever, does it keep getting taller? Does it keep going up height-wise? Yes. Is it going fast? No, it's going by like decimal places. But is it still going up? Yes. And I could scroll, like I said, forever. Okay, some type some crazy outrageous number. Is it still getting bigger? Super slowly. Do you see how it's like barely changing now? Okay, it's growing, but super slow. So does it go up forever? Yes. Does it also go down forever? Well, oh, sorry, this is +infinity. If we looked the opposite direction, which is negatives, is it still going down forever? Again, super, super slow, but yes, it's going down forever. So your range is also -infinity to +infinity, and it will also always be that. Because the graph will always look like this. Now, if you multiplied something in front, it might grow faster. If you divided something in front, it might grow slower. But it's still growing. It's still going to the left and right forever. It's still going up and down forever. So that is what you're doing today.